Welcome student to my channel Educare Maths and Science. Today I discuss the chemistry, the separate part of the chemistry. Already we have to discuss the inorganic chemistry, the new chapters, the new part. This called actually the organic chemistry. Is a different branch of the chemistry. This is the introduction in the class 10 actually. The organic chemistry and inorganic chemistry, these are too much different. Okay. First you clear your concepts. What is actually the organic chemistry? In case of the inorganic chemistry, you know certain idea of the bonding, the ionic bond. Suppose this is the ionic bond, that means Na plus Cl2. Sodium chloride, that is Na plus Cl minus. This actually bonding, the shifting of electrons, you know, these are 281. So 28 shifting of one electron, the chlorine 287 to shifting one electron, that is Na2Na plus Cl to Cl minus. That is actually all of the inorganic compound. Electronic exchange, actually outermost orbit. In case of the ionic bond, the inorganic compound, especially the ionic bond. But in case you just certain idea about the, suppose the O and O, actually O2 is formed. That is actually the sharing of electron. That is called the, this is a 6. Suppose this and this, these 6 electron. So these 2 electrons are sharing. So this is called the bonding. Bonding is developed, not total shifting of electron. That is the sharing of electron. So in case of the organic chemistry, actually total is based on the covalent bond. So there is no ion is developed, other things is there. So practically from the starting, you know that there is a certain difference of the inorganic and organic. Organic is the covalent bond and inorganic especially in the ionic bond. So their difference, their properties also. So now this is the basic concept of the organic chemistry. The in place, you just cannot shift into the inorganic compound to the organic compound. That's a special. The one thing is very introduction here. The organic chemistry. Organic chemistry actually specifically compound derives from the living organs. Organic, any type of organic substance, you just coming from the living organ. Inorganic, the non-living organ. Okay. So organic chemistry basis, the center part is actually called the carbon. Carbon is the main part. So center part is the carbon, and especially maximum hydrogen is combined with this. So actually the organic chemistry, the other name is hydrocarbon. Organic compound mainly compound of carbon and hydrogen. So the other name of the organic compound is the hydrocarbon. 2 or 3 or 4 or 5 elements are there, but huge compound does form in case of the organic compound. In case of the inorganic compound, you know the 100 elements are there, but maximum the 50,000 compound is there. But in case of the organic compound, is a special thing. This is the special property of the carbon. This compound property is called the catenation property. I just coming for that. Okay, so this is the different structure is very important in case of the organic compound. In case of the inorganic compound, there is no need for the structure. But here is the organic compound, the need for the structure. That means in case of the organic compound, already you just chemistry you learn, these all of the inorganic compound. So total pattern of your learning is different in case of the organic compound. Just your introduction here. First, inorganic to organic. In general, there is no linkage between the inorganic compound and the organic compound. Is a separate thing, but because they are the ionic and this is the covalent, clear. Now first inorganic to organic compound one is developed. This is the ammonium cyanide, NH4CN. This is the inorganic compound. If you just heat it, just rearrange their molecules to form urea, CONH2. Urea is formed. That is only these molecules are rearranged itself. Really, molecular rearrangement, the structure. So inorganic to organic, if you just heat it. That is a one example from the inorganic to organic. Only just same thing. N is only 2N is there, 2N is there. Hydrogen is 4, 2 2s are 4, carbon is 1, oxygen. Same thing. But just rearrange. In this way, in case of the organic compound, the structure is very important. So many things are written here for their better understanding and clear your concept. Organic compound, inorganic compound, what is the basic difference? Organic compound, especially carbon is present. Always carbon is present in case of the organic compound, the center part. But carbon is not essential in the organic compound. Suppose sulfur dioxide. What need for the carbon? Okay. But in case of the organic compound, you cannot see without carbon any organic compound, because carbon is the center part. Carbon is the main thing. Okay. Generally, it does not dissolve in water. So here is dissolved in water. That means you just see here the total difference from the inorganic compound and the organic compound. For that I write down. Okay. Generally, it does not dissolve in water. Generally, dissolve in water. Too much difference. Just opposite. Dissolve organic solvent. Organic compound dissolve in the organic solvent, that is alcohol and benzene, but does not dissolve organic solvent. That means you cannot dissolve any inorganic compound in organic solvent. Benzene and other thing, you cannot dissolve the other inorganic substance. Okay. Low MP. MP means the melting point. In case of the organic compound, low melting point, low boiling point, because their bond is very weak. This is a covalent bond. For that reason, the melting point and boiling point of organic compound is very weak. But high melting and boiling point in case of the inorganic compound. Inorganic compound, because it is the ionic bond specially, for that reason the melting point and boiling point is very high. And usually does not decompose on heat. If you just heat, just certain heat in case of the inorganic compound, it does not dissolve. But in case of the organic compound, if you just apply heat, certain dissolve. Okay. Inflammable. Catch fire, because the carbon is there, the fuel is there. So in organic compound is inflammable, catch fire easily. But in case of the inorganic compound, it cannot catch fire. Okay. Maximum covalent, these are all the covalent bond. Organic compound base, the structure, all these things are the base of the covalent bond. You know the sharing of electrons, this is chemical bonding, I just discuss later, but just certain idea. And this is the maximum the ionic bond, sodium chloride, NaCl, Na plus Cl minus. Okay. The first organic compound I just say, the methane, CH4, these are organic. In that I just see you, covalent bond. Non-electrolyte, for that reason, is not passing the electric current in case of the organic compound. But in case of the inorganic compound, there is the ionic bond, the carry electrons. So is a good electrolyte. Very clear to you? Okay, but the very important thing, so isomerism, this is a very important character in this case of the organic compound, and especially the carbon. For that reason, the huge amount of the organic compound is formed. Just rearrange, each and everything, just rearrange. 4 sides are there. Certain example in case of the chemistry, 4 line. You just form a 4 line, a rectangle is drawn, a parallelogram is drawn, a square is drawn, a rhombus is drawn. Just use the 4 lines, you just draw the different structure in case of the geometry. In case of the organic compound, the structure, you just rearrange the structure, new separate compound is formed. But it's not possible in case of the inorganic compound. So these actually form the isomerism. Same molecular formula, but the different their structure, they form the new compound. So huge amount of organic compound is formed. For that reason, this is the special property of the carbon, the catenation property, the isomerism, the structure, very important thing. Now, non-electrolyte, so isomerism is cannot show such isomerism. In case of the organic compound, there is no such isomerism data. In case of the organic compound, the color and order is nil. Color is there, order is there, but in case of this inorganic, most of the colorless or odorless. But in case of the organic compound, the reaction is very slow, because the linkage is there. In case of the carbon-carbon linkage is there. But in case of the inorganic compound, this is an ionic bond. Very quickly the bond is separate, because this ionic compound, suppose is the dielectric in case of the water. Okay, for that reason, in case of sodium and water, just quickly dissolve, because Na plus Cl minus, here is H plus OH minus, the separate. So this is quickly dissolved in water. Okay, so fast reaction. Okay, so in case this is just difference of the, just I write down here the difference between the inorganic and organic compound, the basic thing. The concept must be clear. The new chapter, the organic compound is a new thing in the chemistry, new branch in the chemistry. In case of the organic is totally different in case of the inorganic. So for that reason, the clear your concept fast. Okay, so for that reason here, unique nature of carbon, this is a very important thing. In case of the organic compound, base is the carbon, center part is the carbon. Okay, unique nature, what is the unique nature? The tetravalent. Carbon is the tetravalency. So catenation is a very important thing. Catenation is a very important property. Catenation means actually, here is I down, the property of the self-linking atom. That means a carbon is there, 4 hands are there. So one carbon is linked to other. This is. Okay. Now this is. Okay. Each and everywhere the carbon is 4 hands. 1, 2, 3, 4. Here is carbon 1, 2, 3, 4. But here is the bonding is developed. This actually called the catenation. আমরা চেন বাই চেন এরকমভাবে আমরা করেই দেখতে পারি। C. This property is called the catenation property, the special property of the carbon. For that reason, the huge amount of the organic compound is formed. So this called the tetravalent, 4 valence, 4 hands, catenation property. In that of catenation property, the straight chain is formed, branch chain is formed. I just see you, cyclic is formed, single bond is developed, single bond is there, double bond is there, triple bond is there. Just you show here. Catenation property is clear now. Okay, but other element also, because in case the catenation properties are in silicon or others, but carbon is the maximum catenation property. So because the carbon bond is very strong and the tetravalency and the structure is important. Different structure is formed in case of the carbon. Okay, and now the structure is basically the 4 hand. Each and everywhere you just complete the 4 hands in case of carbon. Okay, because the valence is this. And isomerism means the same molecular formula. Same molecular formula, I just write down here the same molecular formula, C6H12O6. C6H12O6 is the same molecular formula. Isomerism is a very important thing. Same molecular formula, C6H12O6. This is the same molecular formula, but you cannot identify what is this. But in case of the inorganic chemistry, sulfuric acid, H2SO4, you definitely just tell this is a sulfuric acid, H2SO4. There is no other compound is formed. But in case of the organic compound, you cannot C6H12O6, you cannot definitely say is the glucose or the fructose. These called the isomerism, the same molecular formula, but the different are the structure. If the different of the structure, one time is formed the glucose, one time is formed the fructose. This is a very important thing in case of the organic chemistry, the basic thing. You just identify, suppose this is SO2. This always you say, each and everywhere, SO2 means sulfur dioxide. There is no other compound is formed. So definitely you say this SO2 means in case of the inorganic chemistry, sulfur dioxide. This is sulfuric acid. But you cannot definitely say C6H12O6. In particular the glucose or fructose, you cannot know. Because you don't know the structure. So in case of the organic chemistry, structure is very important. Each and everywhere you draw the structure. On the basis of this, these actually called the isomerism. These are two forms. One is glucose, one is fructose. So these actually called the isomerism. Isomerism means the same molecular formula, but different their structure, they form the different compound. Is clear to you? Now, one. This is isomerism. For that is the huge amount of organic compound. 55 million compound is formed. Okay. And the cell banking is clear to you. Bonding, this is this. Now, two main things. One is the straight chain, one is the branch chain. Now, suppose this is the catenation property. Each and everywhere you just practice in your home. In which way the straight chain? Carbon first. So one is there, 1, 2, 3. There go. 1, 2, 3, 4. Okay. So here is carbon 2, 2, 1, 1. Here is carbon 2, 2 hand, 1, 1. Here is 2, 2 hand, 1, 1. Here is carbon, this is 1 hand, 1, 1. Each and everywhere you calculate 4 hands are there. Okay. In this way, just write here. So this is 1, this is 2, this is 3, this is 4. In case of this second number carbon, this is the 1, here is 1, this is 2, this is 3, this is 4. Here is third number, here is 1, 2, 3, 4. Here is, this is 1, 2, 3, 4. Here is 1, 2, 3, 4. I just write down, this is actually the bonding is developed here. Bonding is developed here. Here is the single, only one atoms here, so this is called the single bond. So actually first this is the straight chain. This form the straight chain. Okay, straight chain. Okay, the catenation on the basis of the catenation property, these are straight chain. Now the branch, suppose this and this. Here is one carbon. That means this carbon 1 hand, 2, 3, 4. Here is carbon 1 hand, 2 hand, 3 hand. This is the 4 hand. Here is carbon 1 hand, 1, 2, 3, and here is carbon 1 hand is there, 1, 2, 3. These actually called the branch. This is the straight. There is no branch. Here is straight, but one branch is there. You just add is also branch. So different structure. There is, suppose the 4 number of carbon, you just identify 4 number of carbon, the straight chain and the different. This is the same other form is found. In case of the 4 carbons, one is straight chain and one is branch. 4 number of carbon. 1, 2, 3, 4. 4 number of carbon, this is a straight chain. But 4 number of carbons, this is the branch chain. ISO. That is the difference in case of the organic compound. This is not you just see in case of any inorganic compound. This is the very important thing. So just you complete. This is the 1 hand, 2 hand, 3, 4. Okay. This is actually bond is formed here. This carbon is sharing there. So 1, 2, 3, 4. Okay. In this carbon, 1 share here, 1 share here, 1, 2. 4 carbon share is 1 share. You just complete. Here is the hydrogen, no problem. But this is the straight chain hydrocarbon. Hydrocarbon, why? Because the carbon and hydrogen bonding. Here is one carbon atom share the other hydrogen atom, so it's called the single bond. It's okay. But here is the branch. 1, 2, 3, but this is the branch. Here you complete. This carbon is 1 hand is here. Okay. This carbon, 1 hand here, 1 hand here, 1 hand here. So this is this. 4 hand is complete. Here is carbon 1 hand. This is 2, 3, 4. Okay. Here carbon 1 hand is there. This. This called the branch. Branch chain. Structure is branch. Is clear. Now, cyclo. That means the closed chain hydrocarbon. This is actually called the open chain hydrocarbon. But if the closed means the carbon is closed. Suppose this link. Okay. So what is this? Is the close actually. Carbon 1 hand is there, 1 end is there. This is 2 hand. In this carbon, the first number of carbon, 2 hand is there. So 4 hands. Always you just complete the 4 hands. Very important thing. So 2 hand is there. In that carbon, this 1 hand, this is 1 hand. This is 2 hand is there. Here is the carbon. This is 1 hand. This is called the closed chain or cyclo. Closed chain or cyclo. Here is this is you just in your home you just practice in this way. So this is the hexagon. This is the carbon 1, 1, 1, 1. This you just complete in this way. Now in that carbon, this 2 hand, this is 2. In that carbon, this is 1 and 2. This is 2. In that carbon, this is 1. This is 1, 2. In that carbon, this is 1. This is 1, 2. In that carbon, this is 1, 1, 2. In that carbon, this is 1, 1, 2. So this called the 6 carbon, the closed figure. So this called the cyclic hydrocarbon, or this called the closed chain hydrocarbon. This called the closed chain hydrocarbon. This called the open chain hydrocarbon. Now I just come to the last part. This is the bonding structure, the straight chain. So one is isomerism. This is the property of the catenation property and the bonding. Now carbon develop the single bond, double bond and triple bond in this way. Just use them. You just practice in your room. So this is a new thing. That is first time this is a very complicated, but just you gradually I just try my best to come easier way to understand this. Okay. So this is called the single bond. What? So this is, suppose this one carbon. Okay. Now the other carbon. Here is this. This. Okay. Now two carbons. Now this and sorry, let us read. That means actually this is the bonding developed here. That means here is the bonding. First carbon, these are 4 hands. Second carbon, these are 4 hands. 1, 2, 3, 4. The color is different. Now it's give one electron. It gives one. Suppose here is this is the electron actually, and here is the electron. Here is the electron. This is cross. This is cross. This is cross 4. Now here is this. Suppose this and this, a bonding is formed. 1 electron from here, 1 electron from here. So carbon single bond is developed in this way. 1 electron given by this, 1 electron given by this, the 2 electrons. Now one thing is very important. You just always complete the 8 in the last orbit for their stability. That is very important. For that reason, here you see. Here. Clear? So this for the 2. Carbon bond. Okay. Now the double bond. Suppose this actually called the double bond. Here is carbon 1 electron. Here is 1 electron. Here is 1 electron. Here is. So these two 4 complete here. Actually here is দুটো ইলেকট্রন দিয়েছে, এখানে একটা এখানে একটা, আর এর ক্ষেত্রে দিয়েছে এটা। So 2 electrons supplied. 2 electrons. The carbon is 4 electrons. The tetravalent 1 2 3 4. Here is 1 2 3 4. So here is it gives 2 electrons from here. It gives 2 electrons of bonding 2 2. Actually 4 develop 4 to 8. 4 to 6 to 8. Okay. So this called the double bond. This called the double bond. It's clear to you that double bond means 2 electrons supplied by the each. And here is the next is the triple bond. Here is triple bond. Here is triple bond. That means this. That means here is 3 electrons, here is 3 electrons, and 1 is here. This called 3 electrons is supplied. This called the triple bond. So different types of these. Okay. Suppose here, in case the first, this is a triple bond. In case of the first compound is the methane single bond. This called CH4. The first organic compound methane. This is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. Okay. So here is the carbon electron is dot, and just hydrogen electron is 1 electron. Here is 1 electron, here is 1 electron. Hydrogen, you know the electron number is 1. So supply this 1 electron is there, hydrogen 1 electron, single bond. Here is single bond, here is single bond, here is single bond. So outermost orbit is the 8 is complete. 8 is complete. That means the CH4, the first organic compound, the very simple organic compound, methane single bond. Methane single bond. Okay. But in case of the ethane, just I introduce ethane, CC double bond, hydrogen. The 2 carbons here, C2H4. This is C2H4. Carbon 2 electrons here, 1 electron here, and this is this. Okay. This is hydrogen. C2H4. This is H. This actually form the double bond. Next class I just discuss about this. Okay. So this for today. If you just understand, please share and subscribe the channel. Thank you. The next class I just broadly discuss. This is the basic thing that will be very interesting to you. Okay. That's very okay. Thank you, student. Thank you.